Hello everyone, and welcome to the phone screen solution for the search engine company mock interview. So just to remind you that you should be practicing your non-technical question answers. I gave you some non-technical questions here that you should be able to answer. Go ahead and review the list of non-technical questions earlier in the course to really get good practice on that. As far as the solution for those, there aren't really any correct answers here. Just make sure you prepare to answer with the following questions about the company you're interviewing with. Be honest, friendly, and ready to defend any statements you make with logical arguments to back them up. So if you say, like, Python is my favorite programming language, make sure you have logical arguments to back that up. Note, you should always have follow-up questions. Go ahead and review the follow-up questions list we have earlier in this course. Now, with that being said, let's go ahead and move on to that technical question. So here was the question: write a function that computes the nth Fibonacci number. So there's lots of ways to answer this question, and in an interview setting you might be required to solve it multiple ways and discuss some pros and cons of each way. So we're just going to walk through the various ways of doing it. I'm going to zoom in here so you can really see it. Okay, so we're going to go through about 5 examples here, using a looping technique, using recursion, using generators, using memoization, and then also using memoization as a decorator. All right, so let's go ahead and discuss each of these solutions. So we're not actually going to code anything out, we're just going to talk about this. So using a looping technique, what are we doing here? In this particular function, we're taking advantage of Python's tuple unpacking here. So we say a and b are both equal to 1, and then we say for I in range n-1, we're just looping through that range and resetting a equal to b and b equal to a plus b, that previous a. Then at the end, we just return a. So pretty simple, pretty straightforward. Using recursion, you may be in a situation where in an interview setting, they specifically ask you to do this using recursion to test if you know recursion or not. So let's go over the solution. Here we have our recursion sequence, and then we have a base case. Remember, recursion should always have base cases. So we say if n is equal to 1 or 2, in this case we're starting at 1 and 2. You may have 0 and 1 depending where you start your Fibonacci sequence. Here we're just returning 1. Otherwise, we do a recursive call on the function with n-1 and n-2. And here we're calling on 7. Here we have another example using generators. Here again, we're taking advantage of tuple unpacking, starting at 0 and 1 for this Fibonacci sequence. Say global AB, because we're doing a generator, we have to define it outside of that function. And then say while true, we're yielding it. Really similar to that looping statement, but in this case, we're doing a generator, so you'd have to keep calling next in order to see all the results. Okay, then finally using memoization, in this case without a decorator. So we have memo here, and we're going to take in fn and arg, and we're saying if arg is not already in memo, memo at that argument is equal to argument into that function. And then we'll return memo at arg. So notice how we're using keys here. So using memoization, we're going to pass in that function and the n number we want, and set it equal to an object when we put in memoize. And then if we want to use memoization as a decorator, we can actually make a class really similar in function and scope. We say def init, we initialize with some function, set memo equal to empty here, and then we say again, if arg's not already in that memoization tracker, that dictionary, we set that argument equal to the argument passed into the function. So we're keeping track of things. And then you can use a decorator to pass it into or over that regular Fibonacci looping function. Okay. As far as depicted average relative performance, went ahead and ran this on a computer so you can get an idea here. So we're doing n equals 15,000. And what are the results? Let's zoom out so you can see a little more. Here, if you're using loops, recursion, generators, memoization, and memoization as a decorator, clearly recursion, probably the worst way to go. You should know that in your interview, and that makes sense because you're having to recalculate things over and over again. Remember, we discussed in the recursion section how you can use memoization to improve on just general recursion. Also, loops, pretty straightforward, but probably the better ways to go are taking advantage of recursion through memoization. All right. Again, hopefully you were able to answer at least one of these methods in the question. It's important to get a good idea of how to approach one simple problem through multiple different methods and understand the pros and cons of each of those. All right. Thanks, everyone, and I'll see you at the next lecture.